Hello everyone, hope you're doing well. My name is Tawfiq Omer, teacher of mathematics. In this video I will explain Chapter 1 Lesson 3 Part A, Function and Functionations. Function is a relation between two sets A and B, is the set of order pairs x, y. The relation between set A and set B, it be a function if for all x in A there is only one y in B. When A is called a domain and B is called a range, x is called independent variable, y is called dependent variable. How do you know that a relation is a function? If y in any relation with the power 1, then this relation is a function. For example, y plus 2xy minus x squared is equal to 0. This relation is a function because all y's its power is 1. But in the second example, y equal 2 over 2x minus y is not a function because we have y times y, then this is not a function because y is to the power 2. But if we have a graph of the function, then we use the vertical line test. A vertical line cuts a graph of the function of x at most once. If we have a relation like this and the vertical line cuts this relation only in one point, then this relation is a function. But if the vertical line cuts this relation or this graph in 2 points, then it is not a function. Here it is not a function because the vertical line cuts this relation in 2 points. Here this is a function because the vertical line is cut the graph of this function in 1 point. You have 2 points, but this one is a wholly point because of that this line is not passing through this point. Value of a function. Value of the function, that means the value of y. When x is equal a, then y is equal f of a is called a value of a function. Example number 1. To answer a, b and c, use the function fx equal x squared plus 7. A, the value of fa is equal a 16 a squared, b 3a squared plus 7, c 9a squared plus 7, d 3a plus 7. To find y equal f of 3a, replace in place of x 3a, then you get 3a squared plus 7. 3a squared is 3a times 3a. 3 times 3 is 9. A times a is a squared. Then 9a squared plus 7. You can see that C is a correct answer. B, the value of f b minus 1 is equal a b square minus 2b plus 8, b b square minus 2b minus 8, c b square plus 2b plus 8, d b square plus 2b plus 7. To find y, replace b minus 1 in place of x. We get b minus 1 square plus 7. Opening this bracket, b times b is b square. 2 times b times minus 1 is minus 2b. Minus 1 times minus 1 is 1 plus 7. 1 plus 7 is 8. Then f of b minus 1 is equal b square minus 2b plus 8. You can see that A is a correct answer. C. The value of fx plus delta x minus fx over delta x is equal a x square plus 2, b 2x plus delta x, c 2x square plus x, d x square plus delta x. To find the value of this, first of all, replace x plus delta x in place of x. You get x plus delta x square plus 7. Then minus, in place of fx, replace x square plus 7. Then x times x is x square. 2 times x plus delta x is 2x delta x. Delta x square is delta x square plus 7. Minus time plus is minus x square. Minus time plus is minus 7 over delta x. Then cancelling x square with x square, 7 with 7, remain 2x delta x plus x delta x square over delta x. You have a common factor, delta x, take it out. Delta x remain 2x plus delta x over delta x. Cancelling delta x with delta x, then the answer be 2x plus delta x. You can see that B is a correct answer. Check it out. 1. To answer A, B, and C, use function fx equal 1 over x. A 1 over 3a, B 1 over 9a, C 1 over a, D 3 over a. Replacing 3a in place of x, then f of 3a is equal 1 over 3a. That means A is a correct answer. B. The value of f 1 over square root of 3 is equal. Replacing 1 over square root of 3 is equal 1 over, in place of x you use 1 over square root of 3, then it be 1 over square root of 3, it become square root of 3. Then C is a correct answer. C. The value of fx plus delta x minus fx over delta x is equal. First of all, replace x plus delta x in place of x. It becomes 1 over x plus delta x minus fx is 1 over x. Then it equal x times x delta x in denominator. Then x times 1 is x minus 1 times x plus delta x is x plus delta x. Then opening this bracket, minus time plus is minus, minus time plus is minus, then it becomes x minus delta x over x delta x over delta x. Cancelling x with x and write numerator here, it become minus delta x, x delta x. Change this division to the multiplication, then it is become 1 over delta x. Cancelling delta x with delta x is become minus 1 over x delta x. You can see that the D is a correct answer. Real function. If A is subset of R, that means if the domain of the function subset in the real number or equal the real number, then fx is a real function. One-to-one function. For all A not equal B, if and only if fa not equal fb. That's mean for all two different value for x, there is two different value for y. But if we have a graph of a function, then if a horizontal line cuts the graph of the function at most once, this function is one-to-one function, onto function. If the range is equal the b, if the range equal b, then fx is onto function. Determine if the graph is a function or not. To know that this is a graph of a function or not, draw the vertical line, and you can see that this vertical line cuts this graph in two places, y1 and y2. Therefore, this graph is not a graph of a function, only it is a relation. The second one, when we draw the vertical line, you can see that this vertical line cuts this graph in two places, in y1 and y2. Therefore, this is not a function. Here, you can see that here the vertical line cuts the graph of this function in two places, y1 and y2. Therefore, it is not a function. Example number 3. Determine if the graph is a function or not. Draw the vertical line. You can see that the line, when we draw the vertical line, this vertical line cuts the graph of the function only once in point A. Therefore, it is a function. The second graph, you can see the vertical line cuts only in one point. If we draw here is 1 point. If we draw here, you can see that there is 2 points, but this point is not passing through this line. Therefore, it is a function. Here, too, you can see that the vertical lines cut the graph of this function only in 1 point, but here it cuts in 2 points, here and here. Therefore, it is not a function. Choose the correct choices that describe the following graph. Is this graph of the function is one-to-one or not one-to-one? Now we are drawing the horizontal line. If we draw the horizontal line, you can see that the horizontal line cuts this graph in 2 points. Therefore, this graph is not one-to-one. The second one, when we draw the horizontal line, we can see that the horizontal line cuts 1 point. Therefore, this is one-to-one function. Here, if we draw the horizontal line cuts the graph of the function in 2 points here and here. Therefore, it is not one-to-one function. Here, we drew the horizontal line cuts the graph of this function in 2 points. Therefore, it is not an one-to-one function. Example number 5. If f minus 3 is equal 5 and f of x equals square root of minus x squared minus x plus b, then the value of b is equal 11, 31, 19, 13. Find f of minus 3. Replace in here in this function minus 3 in place of all x. It becomes minus 3 squared minus 3 plus b. Then minus 3 squared is minus 9 plus 3 plus b. Minus 9 plus 3 is minus 6. Then squaring both sides, it becomes minus 6 plus b is equal to 25. Take minus 6 from left to right, then b is equal 25 plus 6, b is equal 31. Then b is a correct answer. You have another way to solve this equation by replacing the value of b in the function and f minus 3. If the result was 5, then it is a correct answer. For example, if we use 31 in place of b, then this equation b, f of minus 3 equal square root minus 3 square minus 3 plus 31. It becomes square root of minus 9 plus 3 plus 31. 31 plus 3 is 34, minus 9 is 25. The square root of 25 is 5. Then it is the answer is the same result. Therefore, the 31 is a correct answer. Example 6. Write the function fx equal to absolute value x minus 1 plus absolute value x minus 3 without absolute value notations. First of all, take inside of absolute value and equal it to 0 and find the value of x. Then x is equal 1. Here x minus 3 is equal 0, then x equal 3. And now draw a line, and then the value of x, we have two values of x, 1 and 3. And now we have 1, 2, 3, 3 intervals. One is less than 1 and the other is between 1 and 3, and the last one is bigger than 3. Using the definition of the absolute value, less than 1, this absolute value is negative. Then is negative x minus 1. Open this bracket, it becomes minus x plus 1. If we replace it 1 here, 1 minus 1 is 0, then it is 0. Bigger than 1, this absolute value is positive, then it is x minus 1. Then replace 3 in place of x, 3 minus 1 is 2, bigger than 1, here is positive, then it is x minus 1. Do it the same with the absolute value x minus 3. Here is minus x plus 3. Replace 1, it becomes 2. Here is minus x minus 3, then it is minus x plus 3. Replace 3 is 0. And then x minus 3 because it is bigger than 3. Because we have summation or plus, use added these two together. X minus 1 plus x minus 3. Here is become minus x minus 3 is minus 2x 1 plus 3 is 4. Then it is minus 2x plus 4. 0 plus 2 is 2. Here minus x with x is cancelling. Minus 1 plus 3 is 2. 2. X plus x is 2x. Minus 1 minus 3 is minus 4. Then 2x minus 4. And now you can write the function. Fx is equal. Less than 1 is minus 2x plus 4. From 1 to 3 is 2. Bigger than 3 is 2x minus 4. You can write it in this way or you can write it in this way. Take equal here x less than or equal 1. Here x bigger than or equal 3. The graph of this function is like this. Example number 7. Use the graph of the function fx and find f of 3. Draw a vertical line on x-axis when x equal to 3. At the point of intersection, draw a vertical line on a y-axis. The vertical intercept is a value of f3. Then f3 is equal to classification of the function. Elementary function fell into 3 categories. First one, algebraical function, polynomial, radical, and rational function. Trigonometric function, sine, cosine, and tangent. Exponential and logarithmic function. The most common type of algebraical function is the polynomial function. The general form for the polynomial function is fx equal f of ax to the power n plus a n minus 1 x to the power n minus 1, etc. until a1 x to the power 1 plus a0, when an minus 1 until a1 a0 are called coefficients, and n is the degree of the polynomial, an is the leading coefficient, and a0 is the constant term. The behavior of the polynomial function at the infinity can be studied according to whether the function is even or odd, and according to the sign of its leading coefficient. The behavior is summarized as shown below. Sign of the leading coefficient of the function an is bigger than 0, that means it is positive. then the degree of the polynomial function is odd, it becomes like this. For example, x approach to infinity. When x approach to the infinity, then fx approach to the positive infinity. And when x approach to the minus infinity, then fx is approach to the minus infinity too. Degree of the polynomial function is even and the leading coefficient is positive, then the graph will be like this. When x approach to the positive infinity, then fx approach to positive infinity. And when x approach to minus infinity, fx remained approaching to the positive infinity. If the sign of the leading coefficient of the function an is less than 0, that means negative, and the degree is odd, then the function will be like this. When x approach to the positive infinity, then fx approach to the negative infinity. And when x approach to negative infinity, then fx approach to the positive infinity. If the degree of the polynomial is even, when x approach to the positive infinity, fx approach to negative infinity, and when x approach to negative infinity, the function is approach to the negative infinity too. Here we came to the end of the video. Please share it with your friends so that everyone get benefit. Please write your comment and subscribe to the page to encourage us. Also press like and bell the ring. Thank you for watching and goodbye.